In this video, we are going to discuss about minimization of DFA. Minimization of DFA means reducing the number of states in the DFA. Here we have a DFA which contains 5 states. So now our target is we have to reduce the number of states in the DFA. We can minimize DFA by using two approaches. The first approach is equivalence method or partition method. The second approach is table filling method or Myhill Nerode theorem. So in this video, we are going to minimize DFA with the help of these two algorithms. Let us see the first approach. So what is the first approach? Equivalence method or partition method. So this DFA is given. Now we have to solve the problem based on the first algorithm, that is equivalence method or partition method, and then we will see the next method. Okay. So first we have to construct transition table. Let us construct the transition table for this DFA. So in this table, the states are Q0, Q1, Q2, Q3, Q4, where Q0 is the initial state and Q4 is the final state. So Q0 is the initial state, next to Q1, Q2, Q3, Q4. So these are the states. Here we are constructing the transition table. Input symbols are A and B. Here Q0 is the initial state, Q4 is the final state. Q0 on A goes to Q1, Q0 on B goes to Q2, Q1 on A, Q1 only, Q1 on B goes to Q3, next Q2 on A goes to Q1, Q2 on B, Q2 only, next Q3 on A, Q3 on A goes to Q1, Q3 on B goes to Q4, next to Q4 on A goes to Q1, next to Q4 on B, Q4 on B goes to Q2. So first here we have to calculate zero equivalence. So in this diagram, the final state is Q4, whereas the non-final states are Q0, Q1, Q2, Q3. So zero equivalence mainly contains two set of states. The first set represents set of non-final states. Second set represents set of final states. So Q0 comma. So what are the non-final states? Q0, Q1, Q2, Q3. Whereas the final state is Q4. In this diagram we have only one final state, that is Q4 only. Now we have to calculate one equivalence based on the zero equivalence. Let us calculate one equivalence based on the zero equivalence. So for that purpose what we have to do is, here the set contains 4 states. So we have to check, we have to compare Q0 with Q1, Q0 with Q2, Q0 with Q3, whether they are equal or not. Okay. Let us take the pair Q0 and Q1 and apply the inputs A and B. Okay. So delta of Q0 comma A is equal to delta of Q0 comma A, that is the first pair, next to Q1 comma A, next Q0 comma B, next to Q1 comma B. We have to calculate all these pairs. Q0 comma A means Q1, next Q1 comma A means Q1, next Q0 comma B means Q2, Q1 comma B means Q3. So after calculation, we have to check whether these two states are present in the same set or not. Okay. Here we have calculated one equivalence based on the zero equivalence. So now we have to check in zero equivalence. Here we got Q1. Q1 is present in the same set. So we can say that this is present in the same set. Next here we got Q2, Q3. Q2 and Q3 is present in the same set. So we can say that Q0 is equals to Q1. Why? Because here these states Q1 means only one state, so that is present in the same set. So likewise here, if here we got the result as Q0 Q3 is present in the same set. But suppose if we got here Q4, here we got Q4, Q2 is present in one set, Q4 is present in another set, then we can say that Q0 is not equal to Q1. But here we got Q2 and Q3, they are present in the same set, so we can say that Q0 is equal to the Q1. Now we have to compare Q0 with Q2, or we can compare Q1 with Q2. Why? Because Q0 and Q1 are equal only. Okay. Let us compare Q0 with Q2. Let us compare Q0 with Q2. So delta of Q0 comma A, next to delta of Q2 comma A, next to delta of Q0 comma B, next delta of Q2 comma B. So what is Q0 comma A? Q1. Next to Q2 comma A, Q1. Next to Q0 comma B, Q2. Q2 comma B, Q2. Here we have Q1. Here we got Q1. Q1 is present in one set only. Here also we got Q2. So Q2 is present in one set only. So we can say that Q0 equals to Q2. So Q0 equals to Q1, Q0 equals to Q2. Now we have to calculate, now we have to compare Q0 and Q3. So for space constraints, I am erasing this portion. So now let us compare Q0 with Q3, or we can compare Q1 with Q3 or Q2 with Q3. Why? Because Q0, Q1 and Q2 are equal only. Okay. So let us calculate delta of Q0 comma A. Next delta of Q3 comma A. Next delta of Q0 comma B. Next delta of Q3 comma B. So what is Q0 comma A? Q1. Q3 comma A is also Q1. Next Q0 comma B means Q2. Next here the state is Q3. Q3 comma B means Q4. Q1 single state, so there is no problem. So it will be present in only one set only. But if we observe Q2, Q4, Q2 is present in one set, whereas Q4 is present in another set. Q2 is present in one set, whereas Q4 is present in another set. So we can say that Q0 and Q3 are not equal. So we can say that Q0 is not equals to Q3. So here Q0 equal to Q1, Q0 is equal to Q2. Now one equivalence means Q0, Q1, Q2. Why? Because these three states are equal. But Q0 is not equal to Q3. So we have to write Q3 in another set. Next here we have one more set called Q4. So let us write that set here. So this is one equivalence. So 0 equivalence is calculated. Next one equivalence is calculated. Next to 2 equivalence, 3 equivalence. Likewise we have to calculate until the subsequent equivalences are equal. Suppose if 2 equivalence and 3 equivalence are the same, then we can quit the process and merge the states. So let us see, let us calculate 2 equivalence. 1 equivalence is over. Now let us calculate 2 equivalence. 2 equivalence. If 2 equivalence result is also same, then we can quit the process. Otherwise, we have to calculate 3 equivalence. So in here 2 equivalence is calculated based upon 1 equivalence. So in 1 equivalence we have Q0, Q1, Q2. Now we have to compare Q0 with Q1, Q0 with Q2, whether they are equal or not. So first to compare Q0 with Q1. So delta of Q0 comma A. Next to delta of Q1 comma A. Next to delta of Q0 comma B. Next to delta of Q1 comma B. So what is Q0 on A? Q0 on A means Q1. Q1 on A means Q1. Next to Q0 on B means Q2. Q1 on B means Q3. Here we have only one state, that is Q1. Q1 is present in only one set, so there is no problem. But if we observe here, Q2 is present in one set, whereas Q3 is present in another set. So we can say that Q naught is not equals to Q1. Why? Because these two are not equal. Q2 is present in one set, whereas here we got Q3. Q3 is present in another set. So we can conclude that Q naught is not equal to the Q1. Now we have to compare Q naught with Q2, whether Q naught and Q2 are equal or not. So compare Q naught and Q2. So delta of Q naught comma A, next to delta of Q2 comma A, next to delta of Q naught comma B, next to delta of Q2 comma B. Q naught on A means Q1, Q2 on A means Q1, Q naught on B means Q2, Q2 on B means Q2. Here we got Q1, Q1, Q1. So here we got only one state. So that state will be in one set only. So Q1 will be in one set only. Here we got Q2, Q2. So one state only. So that will be available in only one set. So we can say that Q naught is equals to Q2. Q naught is equals to the Q2. Q naught is equals to the Q2. Okay. So now we can say that two equivalence is over. Q naught is not equal to Q1, but Q naught is equals to Q2. Q naught and Q2 are equal. So Q naught and Q2 will be in one set, whereas Q naught and Q1 are not equal. So Q1 will be in another set, and the remaining sets are Q3, Q4. Q3, Q4. So second equivalence is over. Now let us calculate third equivalence. If third equivalence result is also same, just like the if it is similar to the two equivalence, then we can stop the process and we can merge Q naught and Q2. Okay. Let us calculate three equivalence. Let us calculate three equivalence. So in three equivalence, we have to check whether Q naught and Q2 are equal or not. Here third equivalence is calculated based upon the second equivalence. So based upon this one only, we have to calculate the third equivalence. So delta of Q naught comma A, next to delta of Q2 comma A, next to delta of Q naught comma B, next to delta of Q2 comma B. Q naught on A means Q1, next to Q2 on A means Q1, next to Q naught on B means Q2, Q2 on B means Q2. So here we got only one state. So one state will Q1. Q1 is present in one set only. Here also we got only one state Q2. Q2 is present in one set only. So here we can conclude that Q naught and Q2 are equal. Q naught and Q2 are equal. Why? Because here the result is available in only one set. So here third equivalence is also similar to the second equivalence. So what is the third equivalence? Q naught, Q2. Why? Because these two are equal. We can say that these two are equal. Q naught is equal to Q2. Q1, Q1, one set only. Q2, Q2, one set only. So next Q3 is one state, Q4 is another state. These two are different states. Q3 is one state, whereas Q4 is another set. So Q1, Q3, Q4. So third equivalence is similar to the second equivalence. So now we can stop the process, and here we can combine, we can merge Q naught and Q2. So we can merge Q naught and Q2 into the one state. Next Q1 will be the another state, Q3 will be the another state, Q4 will be the another state. Initially we have 5 states, Q naught, Q1, Q2, Q3, Q4. Now those 5 states are reduced to 4 states. So this is about minimization of DFA. Now we have to construct the DFA. So what is the first state? Q naught, Q2. Q naught, Q2 is the first state. Here Q naught is the initial state. So let us use arrow symbol. Next, the remaining states are same. Q1, next Q2, next Q3, next Q4. So 5 states are reduced to Q naught, Q2. I'm sorry, there is no Q1. So 5 states are reduced to 4 states. So one state, second state, third state, fourth state. Now let us apply the transition. Q naught on A means Q1. Q naught on A means Q1. Q naught on B means Q2. Q2 means same state only. Next, Q1 on A means Q1. Self loop. Next, Q1 on B means Q3. Next, Q2. Q2 on A means Q1. Q2 on A means Q1, Q2 on B means Q2, Q2 on B means Q2, same. Next Q3 on A means Q1, Q3 on A means Q1, Q3 on A means Q1, Q3 on B means Q4, Q3 on B means Q4. Next Q4 on A means Q1, Q4 on A means Q1, Q4 on B means Q2, Q4 on B means Q2. So this is about minimization of DFA. In the similar way, we can minimize NFA also. The only difference between DFA and NFA is in DFA we can have only one final state, whereas in NFA we may have different final states. So there is no problem. So this can be called as minimization of finite automata also. Minimization of DFA or minimization of NFA. Same approach we have to follow. DFA means the state must use all the symbols present in the alphabet. So Q0, Q1, Q2, Q3, Q4, every state must use A and B. Whereas NFA means if some transition, if some input symbol is not used by the state, then there is no problem. Okay. So in this way we can minimize the finite automata using partition method or equivalence method. Now let us see the second method. Now let us see the second approach, minimization of finite automata using table filling method or Myhill Nerode theorem. Here the finite automata is NFA. Why? Because here we have two final states. Q0 and Q2 are the final states, whereas Q1, Q3, Q4, Q5 are non-final states. Okay. So here minimization of NFA, whereas the first example is minimization of DFA. So same manner we have to follow. So first we have to construct the transition table. So let us construct the transition table. Here Q0 is both initial state as well as final state. Q0 is both initial as well as final. Q1 is non-final. Q2 is also final state. Next to Q3 state. Next we have Q4 state. Next to Q5 state. So Q0. So for space constraints, let us write from here. So Q0 is starting state as well as final state. Next to Q1. Next to Q2 is final state. Final state. Next to Q3, Q4, Q5. So here the input symbols are, 0 and 1. 0 and 1. Q0 on 0 goes to Q1. Q0 on 1 goes to Q3. Q3. Next to Q1 on 0 goes to Q4. Next to Q1 on 1 goes to Q2. Q1 on 1 goes to Q2. Next Q2 on 0 goes to Q2 on 0 goes to Q1. Q2 on 1 goes to Q5. Next to Q3. Q3 on 0 goes to Q0. Q3 on 1 goes to Q4. Next Q4 on 0 1 goes to Q4 only. Next Q5 on 0 goes to Q2. Q5 on 1 goes to Q4. So a transition table construction is over. Now we have to construct one more table. The table will be like this. So here what are the states? Q0, Q1, Q2, Q3, Q4. So let us write them in vertical manner. So Q0, Q1, Q2, Q3, Q4, Q5. Next, let us write the states in horizontal manner. So Q0, Q1, Q2, Q3, Q4 and Q5. Let us eliminate the last state in horizontal and the first state in vertical. Okay. Now we have to establish the connections from each state to remaining all other states. So from Q0 to Q1, Q2, Q3, Q4, Q5. Likewise, we have to establish the connections. So let us see how we can do that. So from Q0 to Q1, from Q0 to Q2, from Q0 to Q3, from Q0 to Q4, from Q0 to Q5. Likewise, from Q1 to Q2, Q3, Q4, Q5. Next from Q2 to remaining all states. Next from Q3 to remaining all states. Next from Q4 to remaining all states. So Q0 to Q1, Q2, Q3, Q4, Q5. Next to Q1 to Q2, Q3, Q4, Q5. Q2 to Q3, Q4, Q5. Q3 to Q4, Q5. Q4 to Q4, Q5. So we have to draw a table like this. Now we have to mark the states. So when we can do the marking, here for marking we can use either a tick mark or cross mark. We can use any symbol. Here we can mark a pair if the pair contains a final state as well as non-final state. We can mark a pair if the pair contains a final state as well as non-final state. If the pair contains only final states, then marking is not possible. Simply we have to leave that pair. We have to leave that box. Likewise, if the pair contains non-final states, then also we have to leave the box. So when we can do the marking, if one state is final state and another state is non-final state. Here what are the final states? Q0 and Q2 are the final states, whereas Q1, Q3, Q4, Q5 are non-final states. So now let us see here. So Q1 to Q1, Q0. So this pair is nothing but this box belongs to Q1, Q0. Or we can call as Q0, Q1. Q0 is final state, whereas Q1 is non-final state. So we can mark this box. Next, this box belongs to Q2, Q0. But Q2, Q0, both are final states. So simply we have to leave that box. Next, Q2, let us see this pair. So this pair belongs to Q2, Q1. Q2, Q1. So one is final state, another one is non-final state. So we can mark this box. Next one, Q3, Q0, or we can also call it as Q0, Q3. Q0, Q3, one is final state, another one is non-final state. So we can mark this box. Next, this box belongs to Q3, Q1. Q3, Q1. So Q3 is non-final state, Q1 is non-final state. So simply leave this one. Next one, Q3, Q2. Q3, Q2. So one is non-final state, another one is final state. So mark this pair, mark this box. Next one, Q4, Q0. So Q0 is final state, Q4 is non-final state. So mark this box. Next one, this pair, Q4, Q1. Q4, Q1. So Q4 is non-final state, Q1 is non-final state. So leave this box. Next, Q4, Q2. Q4, Q2. So Q4 is non-final state, Q2 is final state. So mark this box. Next, Q4, Q3. Q4, Q3. Q4 is non-final state, Q3 is non-final state. So both are non-final states. So leave this box. Next one, Q5, Q0. Q5, Q0. So Q0 is final state, Q5 is non-final state. So mark this box. Next, Q5, Q1. Q5, Q1. So Q5 is non-final state, Q1 is also non-final state. So leave this box. Next, Q5, Q2. Q2 is final state, Q5 is non-final state. So leave this box. Next, Q5, Q3. Q5, Q3. Q5 is non-final, Q3 is non-final. So leave this box. Next, Q5, Q4. So Q5, Q4. Both are non-final states. So leave this box. So here what are the boxes? Those are unmarked. So first one is this one. So next we have this pair. Next we have this pair, this pair, this pair, this pair. Now we have to check whether marking these pairs are possible or not. For that purpose, simply we have to apply transitions. Here what are the input symbols? The input symbols are 0 and 1. So let us apply those symbols. Let us see the procedure. Here this pair is nothing but Q2, Q0. Q2, Q0. Q2, Q0. So let us calculate delta of Q2 comma 0 just like the previous way only. Next, calculate delta of Q0 comma 0. Q2 comma 0, Q0 comma 0. What is Q2 comma 0? Q2 comma 0 means Q1. Q2 comma 0 means Q1. Next, Q0 comma 0 means Q1. Q1, Q1. We don't have any pair like Q1, Q1. So for Q1, Q1, we don't have any box. So let us apply the next transition. So the next input symbol is 1. So delta of Q2 comma 1. Next one is delta of Q0 comma 1. Q2 comma 1, Q0 comma 1. What is Q2 comma 1? Q2 comma 1 means Q5. Next Q0 comma 1 means, what is Q0 comma 1? Q3. Now let us check Q5, Q3 pair. Q5, Q3 pair. Q5, Q3 pair. So this pair is not marked. Q5, Q3. This pair is not marked. So marking this pair is not possible. Why? Because Q5, Q3. If this pair is marked, if one of the pair is marked, either this one or this one. If one of this pair is marked, if either this pair or this pair, if one of this pair is marked, then we can mark Q2, Q0. But here the problem is we don't have Q1, Q1 pair, and if we observe Q5, Q3, so Q3, Q5 means this pair is not marked. So marking Q2, Q0 is not possible. So we have to leave this pair as it is. Now let us see the next one. That is, what is this pair? This pair is Q3, Q1. Q3, Q1. We have to check whether we can mark Q3, Q1 or not. So for that purpose, simply we have to apply the input symbol. So this pair is what? Q3, Q1. So Q3 on 0. Next one is Q1 on 0. What is Q3 on 0? Q3 on 0 means Q0. Q3 on 0 means Q0. Next one is Q1 on 0. Q1 on 0 means Q4. Q1 on 0 means Q4. So here we got Q0, Q4. Q0, Q4. Q0, Q4. Q0, Q4 pair is already marked. Let us see this one. Q0, Q4 pair is already marked. So we can mark Q3, Q4. Q0, Q4 is already marked. This is that pair. So we can mark Q3, Q1. So we can mark Q3, Q1. So we can mark Q3, Q1. So likewise, we have to check the remaining pairs. So for space constraints, here there is no need to apply one symbol. Why? Because here already the pair is marked. Already we have marked Q3, Q1 pair. So there is no need to apply one input symbol. So next one is, so this pair. So this pair is nothing but Q4 and Q1. So now we have to check whether we can mark Q4 and Q1 or not. So for that purpose, simply we have to apply transitions. 0 on Q4. Next one is 1 on Q4. 0 on Q4 and 0 on Q1. 0 on Q4 means Q4. Next one is 0 on Q1 means Q4. So here we got Q4, Q4. But we don't have any pair like Q4, Q4. So now we have to apply the next one. So apply one input symbol. Q4 on 1. Next one is Q1 on 1. So Q4 on 1 means Q4. Q4 on 1 means Q4. Next Q1 on 1 means Q2. Now we have to check whether Q4, Q2 is marked or not. If Q4, Q2 is marked, then we can mark Q4, Q1. Suppose if Q4, Q2 is not marked, then it is not possible to mark Q4 and Q1. Let us check the pair Q2, Q4. Q2, Q4 or Q4, Q2. Both are same only. Q2, Q4. Q4, Q2. So this pair. Q4, Q2, Q4. Or Q4, Q2. Both are same only. So this is that pair. Q2, Q4 is already marked. So we can mark Q4 and Q1. We can mark Q4 and Q1. So let us mark this pair Q4 and Q1. Now let us check the next pair. What is the next pair? This one, this 0. This 0 belongs to what? Q4, Q3. Now let us check whether Q4, Q3 is marked or not. So for that purpose, apply the inputs. Delta of Q4 comma 0, delta of Q3 comma 0. What is Q4 comma 0? Q4 comma 0 means Q4. Next Q3 comma 0 means Q0. Q4 comma 0 means Q4. Next one is Q3 comma 0 means Q0. Now let's check about Q0 Q4 pair. So Q4 Q0. So this is that pair Q0 Q4 or Q4 Q0. So Q4 Q0 pair is marked. So we can mark Q4 Q3. So we can mark Q4 Q3. So we can mark this pair. Now there is no need to apply one symbol. Why? Because this is already marked. Now let us see the next pair. The next pair is Q5 Q1. Let us check whether we can mark Q5 Q1 or not. Q5 Q1. So delta of Q5 comma 0. Next one is delta of Q1 comma 0. So apply 0 symbol. So Q5 on 0 means Q2. Next Q1 on 0 means Q4. Q5 on 0 means Q2. Q1 on 0 means Q4. Now let's check whether Q2 Q4 is marked or not. If Q2 Q4 is marked, then we can mark Q5 and Q1. So let's check Q2 Q4. Q2 Q4 or Q4 Q2. Q4 Q2. Q4 Q2. So this is that pair Q2 Q4. This pair is already marked. So we can mark Q5 Q1. We can mark Q5 Q1. Now let us check the next pair. What is the next pair? Q5 Q3. Q5 Q3. Q5 Q3. So let us apply 0 symbol. Delta of Q5 comma 0. Delta of Q3 comma 0. So Q5 Q3. Q5 on 0 means Q2. Q5 on 0 means Q2. Q3 on 0 means Q0. So Q0 Q2. Let's check whether Q0 Q2 is marked or not. So here we have Q0. Here we have Q2. So Q0 Q2 is not marked. Q0 Q2 is not marked. So it is not possible to mark this pair. So now let us apply one input symbol. Delta of Q5 comma 1 comma delta of Q3 comma 1. So Q5 comma 1 means Q4. Q5 comma 1 means Q5 comma 1 means Q4, correct only. Next Q3 comma 1. Q3 comma 1 means Q4. Q4. Here we got Q4 Q4. But we don't have a pair like this. We don't have Q4 Q4 box. So it is not possible to mark this pair. So marking this pair is not possible. Now let us check the next one. Let us check the next one. So what is the next one? Q5 Q4. Q5 Q4. Let us check whether we can mark this pair or not. So Q5 comma 0. Next to Q4 comma 0. Q5 comma 0. Q4 comma 0. So Q5 on 0 means Q2. Q4 on 0 means Q4. Let us check whether Q4 Q2 is marked or not. So Q2 Q4. This is that pair. Q2 Q4 is already marked. So we can mark Q5 Q4. We can mark Q5 Q4. Now we have to do one more iteration and let's check whether we have two unmarked pairs are there. Let us do the process one more time and let's check whether Q0 and Q2 and Q5 and Q3 are marked or not. If they are still unmarked, then we can merge Q0 and Q2 to one state and Q3 and Q5 to one state. Okay. So let us do that process. So what is the pair? Q0 Q2. Let's check. Here we have two unmarked pairs are there. Let us check whether we can do marking or not. So Q0 Q2. So Q0 on A. Next one is Q2 on A. Next Q0 on B. Next one is Q2 on B. What is Q0 on A? Q0 on A means Q1. Q2 on A means Q0 on here the inputs are 0. So this is 0, this is 0, 1, 1, 1, 1. So Q0 on 0 means Q1, Q2 on 0 means Q1. We don't have any pair like Q1, Q1. So marking that pair is not possible. Let us apply 1. Q0 on 1 means Q3. Next Q2 on 1 means Q5. Now let's check whether Q3, Q5 is marked or not. So Q3, Q5 means this pair. This pair is not marked. So marking Q0 and Q2 is not possible. Likewise check Q3, Q5. Q3, Q5. Likewise check Q3, Q5. So delta of Q3 comma Q5. So apply the symbols Q3 comma Q5. So delta of Q3 comma 0. delta of q5 comma 0. So next one delta of q3 comma 1, delta of q5 comma 1. So q3 on 0 means q0, q5 on 0 means q2, q5 on 0 means q2. So here we got q0, q2. Let's check whether q0, q2 is marked or not. q0, q2, this pair is not marked. So marking this pair is not possible. Next q3 on 1. q3 on 1 means q3 on 1 means q4. q3 on 1 means q4. q5 on 1 means q4. So q3, q5. q3 on 1 means q4. q5 on 1 means q4. We don't have q4, q4. We don't have the box q4, q4. So here with this we can conclude that these two pairs are not marked. So now we can merge these two into one states. We can merge those two into one states. So now the states are, we can merge q0 and q2. Why? Because marking this pair is not possible. q0 and q2 is one state. Next state is q1. Next state is q1. Next here we can merge q3 and q5. We can merge q3 and q5. So next state is q4. So q0, q2, q1, q3, q5, q4. Initially the finite automata contains 6 states. Now those 6 states are reduced to 1, 2, 3, 4 states. Now let us construct the finite automata. Let us construct the NFA. So the first state is q0 comma q2, q0 comma q2. So next state is q1. Next one is q3 comma q5. Next one is q4 state. Here what is the initial state? So q0 is the initial state. And what are the final states? q0 and q2 are the final states. So this is the final state. So let us place them in double circle. For remaining, only single circle is enough. So let us apply the transitions. q0 on 0 means q1. Next q0 on 1 means q3. Next q1 on 0 means q4. q1 on 1 means q2. Next q2 on 0 means q1. Already it is applied. q2 on 1 means q5. Already it is applied. q3 on 0 means q0. q3 on 0 means q0. Next, q3 on 0 means q0. Next, q3 on 1 means q4. Next, q4 on 0, 1 means q4 only. Next, q5 on 0 means q2. Already applied. q5 on 1 means q4. Already it is applied. So here 6 states are reduced to the 4 states. So in this way we can minimize DFA by using 2 approaches, such as the first approach is partition method or equivalence method. The second approach is table filling method or Myhill Nerode theorem.